So, hello everyone. Yeah, we are live now. So, yeah, my name is Nitin Kaplas. So, currently I am mentor at GeeksforGeeks, right? So, today's contest analysis will be taken by me. So, can anybody tell me we are live? Like I am equally audible and visible as well. Please. Okay, okay. Thank you so much. So, how was your contest today's 149 contest? How many students are solved all the questions? So can you please share me in a chat? Okay, Rohit. Okay, Manisha. Thank you. Okay, only two. Okay, Rishabh said two questions. Okay. So okay, solved third, stuck with fourth. Okay. So we will solve fourth one also. Okay. So let me share my screen. Please tell me my screen is visible to you guys so that I can start. Okay, Deepak, thank you. So let's start with the first question. Okay, so let's read the question first. Our question said the name of the question is prefix distinct, right? So let's first read the question. Our question said we are given an integer array, right, of size n, where our task is to return an array answer of size n, right, such that answer I represent the number of distinct element in the prefix of all the array, right, till ith index, right. So let's first understand the problem. So let me take first example, which is n equal to 3, right. Okay, so here n equal to 3 and the array we are given is 1 2 1, right. So in this case, what the question demand from us, we have to return all the answer array, right, in the form of when we are at the ith index, right, we have to count from left side how many distinct element till now we have, right. So if you see in this case, when I equal to 0, right, how many distance element we have? One, right. When I am at this case, right, index equal to 1, in this case, just count how many distinct element we have. Two now, 1 and 2. So we have to store 2 in this case, right. When I am at a, I equal to 2, if you see how many distance element we have right now, 1 and 2, right. So what's the count is 2. So we have to return this, right. We have to return this is our output. Okay, let's see second example. In the second example, if you see, we have one distinct element till now when we are at I equal to 0, right? So we print here 1. After when I equal to 1, we have one element. Again, we printed 1. When I equal to 2, again, if you see in the left side, all are same, right? So here our distinct element till now is again 1. So let me write here 1. When I go further, at the last index, I equal to 2. If you see here, what's the count of distinct element right now? 2 now, 1 and 2. So let me print 2 here. So our output is 1, 1, 1, 2, right? So how we can solve this question is simply here we can use unordered set, right? So what's the case is this is hash set we are using, right? Okay, so when I equal to 0, I add that value into the set, right? As we know, like set only store the distinct element, right? So in this case, I am adding array I. Okay, so if I store array I at I equals to 0, it store 1 here, right? Let me write here s, which store 1. So I equals to 0. How many sizes? So simply size give me the distinct element. So it's 1. So here I am printing 1. Okay, simple. When I equal to 1, I print 2. So I store 2 into my set. Let me store 2 into it. What's the size of set? 2. Let me print 2 here. Okay. When I go further, I equal to 2. It's 1. 1 is already there, right? So what's the size of set? 2. So let me print here 2. So this is my output, right? So let's code this first. So first we have to create a vector, which is v, right? And after that we have to write create the unordered set. And now we are just running the loop. Okay, so first we are inserting it array I. Okay, after that we have to push the size of it, which is s dot size. At the end, simply we are just returning the vector. Okay, so let's compile and check. Yeah, let's submit it. As you see, all the cases are passed. So what's the time complexity of this solution? Simply, we are just creating a hash set, right? And we are just traversing our loop, right? So simply here our complexity is big of n. And what's the space? Again, it's a big of n. Why? Because we are using the hash set here, right? So first is very easy question. So let's move to the second. Before going to the second, can anybody tell me, like, anyone have any doubt in the first? Okay, I solved it by two map, out of which one is unordered and second is ordered. Okay. Okay, Adesh. Okay, so let's move further. Let's move further. Our next question is jumping towers. So how many like candidates solve this question? Like anyone? Okay, second problem is fun. Okay, so let's read the question first. Our question said we are given n towers of varying heights, right? Geeks stand at the top of the first tower, right? In one jump, geek can perform exactly one of the following action, right? So the first operation here is, if geek is currently at the ith tower, he can jump to the I plus one tower, right? And the second operation here is, he can jump to any other tower j such that height of I is same as that of the j, right? So this is very much important. Like many of us like not read this property. So this is the main thing where we are written that he can perform the second action at most one, right? Only one chance is there. Only one chance we can use for the second operation, right, while solving the question. Here we have to find the minimum number of jumps required by geek to reach the last tower, right? Our main agenda is we are at the start of it. We have to reach our destination is at the end of the index of the given array, right? We have to return the minimum number of jumps, right? Simple question. So to solve this question, we can take these two operations. We can use these two operations, and here the condition is we can use second operation only once, right, while solving it. Okay, so let's first try run the first case, like how we can solve it. So here 1 2 1 3 2. Okay, so let's take the first example, 1 2 1 3 2. Okay, now we are at this index, right? We are at this index, and our destination is this. Okay, this is our destination, right? So the first thing is, if we are at height, for example, at ith index, right, and we can move to I plus 1th index in one jump, right? Okay, so we can use this operation n number of times, any number of times, but the condition is, if I am at height I, right, if this height is equal now at any position j, so we can jump to that index, right? So only one time, only one time, only one time we can use this operation. So let's see it. Let me first erase this. Okay, so for example, we are at this, right? To move forward this case, when I am at index 0, when I go further, so can you assume like one jump we can take here? Okay, again one jump here, again one jump here, again one jump here. How many jumps are there? 1 2 3 4. So let's store here 4 if I do this thing. Okay, we need minimum number of jumps. Let's suppose here we have 1. Let's move forward first. Here, how many jumps needed? One jump, right? Now 1 2 3, because no one is there and we are using that operation one time, right? Now one step, which is 3 steps, right? Simple. Now if I don't want to use this thing, let's see another case. When I'm here, I go one step here, okay, one jump, and just see it. This power we are not using till now for this case. So if you see, this is 2, this is 2, and we can make this jump, right? This is second jump. Okay, so here minimum is 2. What's the minimum? 2. This is our answer. Okay, 2 is our answer. Hope you understand the questions, right? Let's do the dry run for another one case so that we can easily understand. 1 2 3, 1 2 3 3 2 4. 1 2 3 3 2 4. Okay, so if you see, I am at currently here. Okay, so here where I can go, if I go this case one step, okay, 2 to 2, 2 step, this is 3 step. If I use power at this index, right, how many jumps we have? We have 3 jumps here. Okay, if you see here again, let's see another case. When I'm here, I have 3, right? I have 3. One step here, one step here. Again, for 3 element, I again use that power, but using that power, I can only reach to next index of it, right? Again, one step, one step. How many jumps here? One step, 2, 3, 4, 5. So here jump is 4, right? 1, 2, 3, 4. Okay, it's 5. So what's the minimum here? Minimum is 3. So our output is 3. Okay. So how we can solve this question? Let's do the dry run for this case. It's, I think it's good test case. 1, 2, 3, 3, 2, 4. Now just see this thing. When we are here now, when we are at here, like for example at 2, right? First index. I just see in the right side of it. I just see in the right side of it so that I can use the power efficiently, right? Which we can use only one time, right? We have power one time. If you see here, what I'm doing in the dry run case, I see 2 is, where is 2? Here is 2, right? I see in the right side of my array, right? So that I can take minimum number of jumps, right? So from this analysis, I can tell you that we can do our question just visualizing from this case, just from this case, right? What I'm doing here is, if I store right elements and its index somewhere, I can easily solve this question, right? I can easily solve this question, right? Just moving from this case to this case, right? So let's do the dry run, how we can use. Here we are using the unordered map because we need element as well, we need the index as well. So let's make first map, right? Unordered map I can use here. In the dry run part, as I said, when I'm at index 1, at element 1, I just need the element 2 in the right side of it, where it is, this side. So here the indication is we can start traversing this given array from the right, right? Right to left, right? So let's see this, how we can do this. If I am here, if I am here, let's start with this. Currently, I am I equal to 5, right? I equal to 5. My element is 4. Just search. In my map, 4 is there or not? Just think this thing. No, not 4 is not there. Let me store here. 4 is at index 5. Here, element is there. Okay. So this represent me index, right? Now, when I equal to 4, right? What's the element is? I am here. What's the element? 2. Is 2 is present in map? No, it's not. It's not. Let me store here. 2 store at 4th index, right? Now let's move forward. Now I equal to 3, right? Just think about it. Like 3 is present. No, 3 is not present. Let me store 3 value at index 3. Now again we move forward. Now we are at this. Just see this. When I equal to 2, my 3 is present in it, right? My 3 is present in it. So what I'm doing is, the power which we are given now, just think we can use here. We can use here. My initially answer is, suppose maximum jump, what is it? 1 jump, 2 jump, 3 jump, 4 jump, 5 jump, right? Let me store here 5, which is n minus 1 we can store, right? Generalized form n minus 1. This is a maximum jump. So if I am equal to 2, 3 is there, 3 is present in map. What I am doing here is, I just use that power at 3, right? One time we can use. So what I am doing is, here I am writing answer equal to minimum of, currently it's 5, right? Answer n minus, okay, n minus, where it's find in the right side, minus current index, m of array of I, right, minus I index, right? So this is a simple step. Let's do the dry run for that so that you can understand better. So if you see, my answer is 5, right? My n is 6. Let me write here 6. Okay. So what's the value? What's the index? 3. Your 3 is present. If you are at I equal to 2, 3 is present at index 3, right? If you see here, Okay, I'm getting it's 3. Let me write here 3. Okay, now you can utilize your power at this case, right? I just write here the current index, which is 2. If you see here, this give me answer 5, right? If you use power at value 3. So let's do the dry run again, so that we know that if I use this power here, okay, currently I'm here, one step to reach this case. Again, if I use power, this step, I can just move to one step ahead. Okay, after that, the power is over, right? We can simply go one step ahead, one step ahead. What's the count of jump? 1, 2, 3, 4, 5 now. That's I store here. Okay, I hope you understand till now. Let's move forward. Now I'm here. Okay. I just update my answer equal to 5. Normally it's 5. Again it's 5 if I am I equal to 2. Let's do this for. Let's I equal to 1, right? The value 2 is there. Just check. It's present in my map or not? Yes, it's present. It's present. Where it is present? It's present at index 4, right? At index 4. So here, sorry, it's index 4. Here it is present, right? So simply just do this thing. Total jumps is 6 minus where it's present at index 4. Okay. 4 minus. Currently I am at I equal to 1, right? So simply give me 3 steps, right? 3 steps. It simply tells you that key, you just decrease this steps. 4 minus 1, 4 minus 1. Total step 4, 6 minus 4 minus 1 you decrease from this, which give me 3. So just do the dry run. If I am here, one step for to reach this case, second step to this case, third step to this case, right? So total step is 3, right? So let's move forward. Currently my answer is 3. Now when I am at reach I equal to 0, just think, one is present. No, it's not present. Let me store here. At the end of my this array, I just return what is in my answer variable. So it is 3. My answer is 3, right? So let's do the code here. So the first step is we have to create the unordered map. Okay. After that, what I'm doing, just traverse from the end, which is n minus 1 to I equal to 0, right? Now, here we have to find first. M dot find if my array I is in my map or not. So currently it's not. So what I'm doing is I just store that value, right, as its index, right? If it's present, I just find the minimum as I can, minus I, right? At the end of it, we just return answer, right? So let's create first answer. Answer is n minus 1, right? As I said, the simple, if you go, you can go with the one step ahead, one step, two step, three step, four step, five step, right? If your n equals to 6, right? So maximum steps here is 5 to reach the end of it, right? Let's check it's working fine or not. Yeah, the compilation is good. Let's submit and check. Yeah, as you see, it's pass, right? So what's the time complexity? Simple. We are just traversing one loop, right? So its complexity is big of n and space is, as we use here map. So big of n is my space complexity here, right? Okay. So anyone have any doubt in this question? You can ask, like, I'm happy to help if anyone have any doubt, so that I can again, like, try to understand you, like where you are having doubt. Okay, so can you give me three any like okay, for three we have three space. Okay, let me write here. Who's the name? Yeah, Adesh, you give me any test case so that I can try run. Where you have any like any problem? Okay, okay, are we okay? Just do the dry run, Adesh, for that case. Like if you have any doubt in the third three or more identical numbers, just do the dry run of this case. You can easily solve with the use of what I am doing in the question. Okay. Okay. If condition. Okay. So if condition is simply here, like if my array in the right side is present, like for example, if my value in the right side is present now, so here we are just doing this case. We are just using that power at that index, right? If for example 2 is present now in my map, right? It's present at index 4, right? So when I reach again at 2, so I use that power at 2, right? So 2 is at index 1, right? So what I'm doing is my maximum step is 6 minus matlab 5 step is there. What I'm doing is 6 minus, I'm reducing the jumps here, right? 4 minus 1. I'm doing here 4 minus 1, which give me 3. It means that when I reach to this element now at this index, to reach, we can simply make one jump, right? To reach to that index. This 2, this 2, right? This is a simple step of it. And currently we are at here. So to reach to this, we need one jump, to this one jump. At the end of the array, we again need one jump. So total number of jump is 1 1 1, right? Which is equal to 3. Okay. So let's move for the next question. Our next question is beautiful cities. So let's read the question first. Our question said, there are n cities in the Geekland. Each city is given some beautifulness by the king, right? Cities with different beautifulness don't like to trade with each other, right? This is the important step, right? The value which are same, they are not like to trade with each other. Okay. You are given with q queries, right? We are given the q queries, each consisting of two integers, u and v, right? You need to tell if all the cities from u to v can trade with each other or not, right? It's also a very simple question, right? How we can solve this question? Anyone solve this question? Okay, okay. Adesh solved that. Can we solve this question using normal loop? Okay, this question. Ravi, you are asking for this question, third question. Okay, okay, okay. Okay. I solved with union, fine, but got TLE. Okay. Using normal loop. Yeah, we can use normal loop here in third question. Simple. Yeah, if we are using any like map or set now, so we got TLE in this case. So let's discuss this question first. So let's first copy paste this. Okay. So here my n value is 8, right? We are given array, right? This array 2, 2, 2, 2, 1, 1, 1, 3, right? So first, let me explain the problem, right? We are given a query, right? This is the array we are given 5 queries. So let's first understand the first query. So first of all, I just convert that query into zero base indexing, right? Here we are given a one base indexing. So let me write here 03 first. Okay, so let me write here as well 03. Okay, so if what we want, we have to check 0 to 3, all the values should be same at any element, like any element will be there, like 2, 1, 3, 4, but it should be same, right? It should be same. If all the elements from this query, this range 0 to 3, 0 to 3, it's same, yeah, it's same, we have to create a vector which we have to push, like we have to push that value into it, which is 1 if it's same. If it's same, we have to push 1. If it's not same, we have to push 0, right? Simply 1 tell you can trade, 0 tell you cannot trade, right? Okay, so let's move forward. Our second is, our second query is 2 5 now. So let me write here 1 4 because zero base indexing. Okay, so let's check this 1 to 4, right? If you see here, duplicates element will be there, right? Like 2 is there, duplicate is there, but 1 is different, right? It means that we cannot trade, right? Simply we push 0 into it. Okay, let's move forward. We have 5 7. Okay, so 5 7 simply means 4 6, right? Let's check in the 4 6. This is 4, this is 6. All the elements are same, right? 1 1 1. Let me push here 1. Okay, now let me erase this first. Okay, the next is 1 8 means 0 7. We have to check in the 0 7. If you see this now, there are many, like they are not duplicate, right? We have 1, we have 2, we have 3. It means we have to push 0 here. Okay, after that we have 6 6 means 5 5, right? So single element is always same, right? So we push 1. So this is my answer, which is 1 0 1 0 1, right? So simple idea to solve this question is, what I'm doing here is I just run the loop up to my queries, right? Simple. The first approach which came to my mind is simple, like I just, as I said earlier in the first question, if we are like taking the idea from the first question, here my first query is this 0 to 3, right? I'm creating a map here, or we can create here hash set, right? And what I'm doing is I add all the values into it. I add all the values into it from 0 to 3. If the size is 1, if the size is 1, right? Then I push 1 into it, else 0 into it, right? Here I'm writing start, simple. Start is equal to query ka first, right? And I'm writing here end, which is query 1, right? So simply just traverse that start to end in my this beautifulness array, right? And value I just put into my hash set, right? And if the value size of my hash set is 1, we simply push 1, else we are pushing into my vector 0. But problem here is our complexity go n into q, right? Let me write the pseudo code. So here what I'm doing is my j is start -1 to end -1, right? And I'm pushing all the values into it. After that, if the size, here I am writing if size s dot size, equal to 1, we push 1, else we push 0, right? This is a simple idea of it. But it got TLE, right? Now, how we can solve this question? So, to solve this question is, let me first create the array. It's 2, 2, again 2, 2, 1, 1, 1, 3, right? Now, the main idea is simple, right? The first thing which came to my mind is, while solving this question, is like, if I do this thing, like this is same, this is same, this is same, this is also same. If I convert this element into any index, right? Any index, I just convert that element into index. Let me convert that first. So this is 2, right? So what I'm doing here is, I want that element. I just modify this array, right? This is modified array. Same array, same array. This is array. This is modify array of it, right? So if you see, this is 2 now. What I'm doing here is, my previous value, let me store here, previous is 2. So what's the index here is 0. Let me write here 0, right? So that the modify array should be in the sorted order. So we can easily calculate that range is equal or not. All the elements in that range is equal or not, right? Now I mark this, okay? Now I'm reaching to this case. Okay, what's the value here? What's the value here? 2. Is this match with my previous? Yes, it's match. It's match. If it's match now, what I'm doing here is, if this is 0, I just convert into code base. Like if I make this element as 0, again, this is also 0, right? Okay. Now I just update my previous, which is 2. Previously it's 2. Now it's also 2. Now I move further. It's 2. Yes, it's 2. It's matched with previous. Yes, it's matched with previous. Let's modify this element as 0 as well. Just copy the previous value. Okay. Just copy the previous value. Now when I'm reaching to I equal to 3, right? Again, it's matched with my previous. Let's copy previous value into this, which is 0, right? This thing I'm doing here. Okay. Now it's time to change it. Now it's time to change it. If you clearly see, this is 1. My element here is 1. It's not matched with my previous value where I am writing here. It's not matched. Let's create another code name here. Code name is its index. Let me write here 4, right? Now when I move forward, before moving forward, what I'm telling you, we have to create the previous value. We have to store the previous value. What's the previous value here? 4. Let me write here. It's match. If I equal to 5, it's match. Yes, it's match. So I just copy the previous value, which is 4. Let me write here 4. Okay. Now, when I move forward, I equal to 6. Again, it's matched with my previous value. Let me write here 4. Right. Okay. Now, when I move forward, what I see, I equal to 7. It's not matched with my previous value. Let's create another name of it, which is index, which is 7, right? Which is 7. So I simply modify my actual array to this, right? This simply tells you that from this to this, all the value are same. From this to this, all the value in my actual array is same. From this to this, it's match. It's equal, right? All the elements are equal. So my main motto is, I just want that array into the sorted order, right? Just putting the indexing into it. Okay. Now let's move to the main part, which is query part. So let's see. What's my first query? First query is 1 to 4 means 0 to 3. So what I'm doing here is, I simply check this value, this value, it's matched. Yes, it's matched. It means all the value in between it's matched, right? It means they can trade with each other. Simple. Let's print one here. Okay, let's move forward. Let's check for other case. Now I have 2, 5. If I convert into zero base, what I'm doing here, 1 and 4, right? Let's check in the range of 1 to 4. So this is 1, this is 4. If you see, it's not match, it's not match. If it's not match, write 0, right? If I move forward, query is 5 to 7 means 4 to 6, right? 4 to 6. Now check in the 4 to 6 part. Let me erase so that you can see. 4 to 6. Yeah, 4 to 6. It's match. This value is match with this. Simple words. This is my start. This is my end. It's match. It's match. Let me write here 1. Again, if I move forward, Q is 0 to 7, right? So this is 0. This is 7. It's match. It's not match. Let me write here 0. After it, we have 5, 5, right? So 5, 5 is a single element. This is its match. Yes, it's match with itself. So let me push 1 into it. This is my answer. Simple. So let's code this. So the first step is I have to create a vector where I am adding my answer. Let me write here V is the name of it. Now, while modifying the array, what I'm doing is, first thing is I have to store the previous value, which is beautifulness 0 value. Let me first store the index 1 value, and I just update that modified at index 0 is 0 because its index is 0 at that place, right? Now we have to move forward from 1 to n. Okay, inside this, what I'm doing is, the first thing, my current value is I, right? Now it's time to check with the previous value, it's match or not. If previous, or say as if current equal to previous, yes. If it's previous, I have to update that index, or say as that index with the previous index if it's match, right? If it's not match, that index value is I, right? So it's a simple step. When we solving I equal to 1, what I tell you, we have to update the previous value as well. So previous is current, right? So this make my array modified just into the sorted manner using the indexing part, right? Now let's check the query part. In the query part, as I said you, the first thing, for example, I write start and here I'm passing query, right? Okay. And end is queries I1. Okay. And here start is -1 because I want 0 base. Okay. Now we have to move from start to end, right? Start to end. So what I'm doing here is I just check the start index is equal to or not, right? So let me check here if start equals to end or not. If it's equal, so let me create here. Okay, I already created a vector. Okay, so if it's equal, what I'm doing, I just push the value of it, right? I just push 1, else we are pushing here 0, right? At the end, we just return my vector, right? So let's compile and check it's working or not. Yeah, the sample case is good. Let's submit and check. Yeah, as you see, all the cases are passed, right? So what's the time complexity in this case? So if you see here, what I'm doing in the first loop, I just traverse up to n, right? I just traverse up to n, and inside it I just compare the values, right? It's the constant part, right? So its complexity for this case is big of n. In the second loop, what I'm doing is I just traverse the number of queries we have, right? Inside it, we just compare the value and pushing into my vector, right? So its complexity is big of q, right? So what's the complexity in this case is big of q plus big of n, right? This is my time complexity. Okay. So anyone have any doubt in this case? Here we just like convert the array into the indexing part so that we can just compare the last indexing, right? Okay. Thank you, Adesh. Anyone have any query in this case? Like I can like I also tell you again if anyone want. Okay, okay. Thank you, RV. Thank you. So let's move for the last question, right? Okay. So it's a little bit tricky to solve this question. So let's solve this first. Let's read the first of all we have to understand this question, right? So okay. First understand this question, right? It's a little bit tricky to understand. Like the name of this question is maximize the minimum importance, right? Okay. So let's read the question first. Our question said you have an integer array, right? Which is called ARR with the size of n and two integers, right? R and K we are given. Okay. So this is the simple given steps, right? We have to repeat the following operation at most K times, right? Select any index I where we have I in the range of this and increase the value of array I by 1, right? We can increase the value of array I by 1, but at most we have k operations, right? We can take at most k times. Okay. So once you have completed the k operations, our main objective is to determine the maximum possible minimum importance of the element in the array, right? So what's the meaning of here importance? The importance of an element and index I in the given array is calculated by the sum of all the elements in the range. This is the given range, right? Okay, this is the formula where we have to calculate all the sum of it, right? All the sum of the given element, right? Let's do the dry run to understand the question better. So for example, if we have this case, okay, so here if you see, let's first write the name of it. What's the name? Maximize the minimum importance. Maximize the minimum importance. So if you see, my array is 1, 2, 4, 5, 0, right? And the value of k is 2, right? My value of k is 2. Okay. So what I'm doing here is they tell me like you can choose, you can take k operation, and in every k operation, what I'm doing is I just increase my array I with one value, right? Okay, this is a simple step. Now, suppose that how many k is there? 2 is k value is 2, right? If you clearly see this thing in the k part, for example, if I increase 2, for example, at one value, right? At this value. So let me first modify this array. it should look like this: 3, 2, 4, 5, 0, right? It should look like this. Okay. So here, if you see, my formula is max of 0. What's the range is max of 0, I minus r. Okay. And minimum is I plus r n minus 1. This is the range we are given. If you calculate this thing, if I use the k operation at the index 1, there are many possibilities, right? There are many possibilities. Let's take some of the possibility and understand this question. So if I equal to 0, I just take that k value at the I equal to 0. Okay. So in this case, what I'm doing is, so my, let's first do the operation for this. Okay. Let's do the operations. Okay. 1 second. Okay. Now, for example, my j equals to 0, right? My I equal to 0 for where I am creating the value, right? Where I am adding that value. Add first index first, right? Now, for example, j equals to 0, I have to calculate that maximum sum, right? So max of 0, I minus r. R you should given, which is 1 here. Okay. So max of 0 or I minus r. I is 0. 0 minus r, which is minus 1. So what's the max of it? 0. Let me change first 0 here. So you are get 0 in the first case, and in this case I plus r, I 0, so I plus r, which is 1. So what's the value here? 1, because n minus 1 is bigger now. We need the minimum, right? This is a formula given. It means that you have to add all the values at j equals to 0. Let's add first. What's the value here? If I add 0 to 1, what is it? 3 and 2. Let me add first. This is 5. Okay. Let's move forward. When j equal to 1, what should my formula look like? The range look like? It's 0 to 1 minus 1, which is 0, right? And here, if you see, r is fixed, right? R is fixed, which is 1. And here my I is, sorry, you can replace with j here, right? Just replace with j, because I am using here j, right? So j plus r, j1, r1, which is 2. So the range is 0 to 2. Let me first add all the value 0 to 2, which is 3 plus 2, 5, 5 plus 4, 9. Let me write here 9. Okay, let's move forward. J equal to 2. Okay, j equal to 2. In this case, my formula should look like 0 to 2 minus 1, which is 1. Here, j plus r. J plus r, j is 2, r is 1, 3, right? Let's see this. 1 to 3. What's the sum of it? 1 to 3, sum is 11. Let me store here. Okay. Let's move forward. J equals to 3. Right now, if you move forward, here j is 3, r is 1, it's 2. And here j plus r, which is 3 plus 1, which is 4, right? 2 to 4, we have to add all the values, which is 4 plus 5 plus 0, which is 9. Okay. Let's move forward. J equals to 4, it should look like j is 4 minus 1, which is 3. Here we have j plus r. What is j plus r? J plus r is 4 plus 1, which is out of bound in this case now. That's why n minus 1 will be given. N minus 1 is 4, right? So we have to take 4 here. So 3 to 4, our addition is 5. Okay. So this is the elements. Let me rewritten here. Let's read this thing. Okay. So just think this thing. When j equal to 0, we have 5. J equal to 1, we have 9. Okay. J equal to 2, we have 11. This is 5, 9, and 5. Okay. So let's move forward. This should store like this. Let's move forward. I equal to 1. When my I equal to 1, it means that my original array is this now. This is original array, right? Original. Okay. So let me add that two values in this case, right? In this case. So it should look like 1, 2 plus 2, because k is 2. Let me write here 2 plus 2, which is 4. After that, we have 4. After that, we have 5. After we have 0. Okay. The same thing we have to do for this, right? Same thing we have to do for this. Here we are adding k value to the single index, right? You can split also. I just make a possible cases so that you understand the question first, right? Now here, my j0, same thing we have to do here. So if you just copy paste the thing, here my value is 0 to 1, which is my sum is, for this case is 0 to 1, which is 5. Let me write here 5. When j equal to 1, its range is 0 to 2 na, 0 to 2, which is 9. Let me write here 9. When j equal to 2, it's 1 to 3. 1 to 3, which is 13, right? Let me write 13. J equal to 3. Range is 2 to 4. 2 to 4, we have 9. Okay. When j equal to 4, we have 3 to 4. 3 to 4 is 5. Let's write 5. When I equal to 2, let's do this for last. This is the last possible. So in this case, if I just compare with my original array, which is 1, let me add at second index, right? So it is 2, this is 6, it's 5, it's 0, right? Okay, so here what I'm doing is I just applied k operation at this index. Okay, let's do this. When j equal to 0, my addition of this is 3. Let me write 3. When j equal to 1, addition of 0 to 2 is 9. Let me write 9. When j equal to 2, range is 1 to 3. 1 to 3 means 13. Let me write 13. When j equal to 3, my when j equal to 3, 2 to 4. 2 to 4, we have 11, right? J equal to 4 is 3 to 4, right? We have 5. Okay. Okay. So let's move forward. When my j I equal to 3, what is my array? My array is 1, 2. This is 4. Okay. So we have to add here, which is 7, 0. Okay. I just do dry run so that you can understand here. Okay. So let's do this again. So when I am j equal to 0, so 0 to 1, which is 3, j equal to 1, what is that? 0 to 2, which is 7, j equal to 2, we have, what do we have? 0, 1 to 3. 1 to 3 is 13, right? When j equal to 3, what's the range is? 2 to 4. What's 2 to 4 is? 11, right? When j equal to 4, what's the range is? 3 to 4, which is 7. Now let's stop it here, right? So just do the trial for this case. I equal to 4, right? So you have something like this. Okay. Now you do this thing, right? You have these elements. Okay. So what's the question is? Question is maximize the minimum importance. So here the importance you are calculating, right? Importance. These are the importance, right? These are the importance with the, you can solve using this formula as you see in the question part. Okay, this is a importance formula. So you are finding all the importance, right, at every index, right? So let's understand from right to left. Importance you calculate, we have to find the minimum. First we have to find the minimum out of my importance, right? Let me write here, this is a final, which element go for the final round. Let me write here. Okay, if you calculate here, what's the minimum element here? 5, 9, 11, 9, 5. What's the minimum here? 5 now. Let me write here 5. Okay. Let's I equal to 1. What's the minimum out of this elements? 5. Let me write here 5. Okay. I equal to 2. What's the minimum here? Minimum is 3 now. Let's write 3. If you see here, what's the minimum? 3. Again, when I equal to 0, something like or you can say that it's 6 or 7 value. For example, let's take this, but it's less than these values, right? Okay. Okay, sorry. This value should be greater than these values. When I equals to 4, this should be greater, something like that. Let me write here, it's smallest. Let me write here 2. Okay. Okay, let's do the dry run for this case now. Again, I equal to 4, j is 0. When j is 0, 0 to 1 is, here I am increasing this. When j equal to 0, we have 0 to 1, which is 3. When j equal to 1, we have 0 to 2, which is 7. When j equal to 2, we have 1 to 3. 1 to 3 is 6, 13. Okay. When j equal to 3, we have 2 to 4. 2 to 4, we have 13. When j equal to 4, 3 to 4. 3 to 4 means 9. So what's the minimum out of it? 3. So let me write here 3. Let me write here 3. Okay. So you have all the minimum importance, right, from each possible values. It's not the each possible, like I just distribute k operation to a single element, right? You can also split. So these are the possible, like, elements which goes to the final round. Now we have to find the maximum out of it. Importance we calculate, minimum we store here. Now it's time to calculate the maximum of the minimum importance. What's the maximum here? 5 now. 5 is the maximum. This is my answer, right? This is my answer. Output here is 5, right? Okay. So this is a question, right? Now how we can solve this question? How we can solve this question? This is a, like, a tricky thing. How we can solve in a given constraint? If I tell you 5 is my answer, for example, not 5, let's take a generalized value. Let's take x is my answer. Let's take x is my answer. Okay, let me write here x. If I have final round values, which is 5, 5, 3, 3, 2. For example, these are the elements which came to the final round, right? Just think about this thing and this x value. Okay, let me tell you 5 is my answer, or let me write x equal to 5 here. Okay, let's think this thing. X is my answer, which is 5. Can x plus 1 may be my answer? X plus 1 will came into my final round. Just think this thing. Just think this point. If x is my answer, just think this point. X plus 1 can be into my final round. No, na. No, it's not. It's not. Why? Because I take maximum of the minimum value. 5 is my answer. There is nothing 6, right? There is nothing 6 element into my final round array, right? So let's move to the left part. Can x minus 1 may be my answer in the final round? Yes, yes, it may be. It may be. So there may be 4, or there may be x minus 2, there may be x minus 1, but the main question is x minus x plus 1 not, x plus 1 not, right? Okay, so what I'm trying to say here is this question is simply using binary search. Binary search, using binary search we can solve this. Why binary search? Because of this idea, right? Because this is my pivot, right? For example, this is my answer. Here, it may be my answer, but in this case, there may not, this may be, this may not be my answer, right? So I have to neglect one half, right? I have to neglect one half. I go into that case, right? Okay, simple, right? So here, what I'm doing is in the question, if you are given this values, 12450. Let me write here 12450. Okay, the value of k is 2. Okay, so what's the minimum value in my binary search? What's the minimum value? Let's write 0 as my minimum value, right? Okay, we can write any element from this, but let's take 0, right? Because we already take the binary search. Okay, okay. So in the ending part, what will be my maximum answer? What will be my maximum answer? Maximum answer will be maximum. It's not a possible answer, but let's take the maximum value. What's the maximum value? Add addition of all the array, right? Which is 1, 2, 3 plus 4 is 7 plus 5, which is 12, right? Okay, but don't miss this thing, right? We have also add this 2k value into my array, right? At an index, it means plus 2, which is 14, right? Which is 14. Okay, so what I'm trying to say is my range is from 0 to 14, right? So what I'm doing here is I find the midpoint. I find the midpoint and I'm checking that midpoint is my answer or not. That midpoint is my answer or not. It may be my answer or not, right? If it's my answer, I'm storing that answer in an answer variable. For example, this, right? As I said you earlier, if this is my x, this may be my answer. Okay, this may be my answer. Okay, so let's assume your mid is, like for example here. Okay, mid is here, but I want the maximum out of the minimum importance, right? Maximum value, the maximum value which satisfy your condition, right? For example, your mid is here. So what I'm doing here is I store that x minus value here. Okay, I my low value, for example, low is here, high is here. Now my low is going after the mid, means here, mid plus 1. Okay, here it's my low. Same thing, what I'm trying to say is this, I store the value, right? And I go further to the right side of it. Here is my low. I search from this case because my answer is this now. My answer is this. Okay, so I simply store the value and low is going into this part. Okay, in the right side. If it's not my answer, what I'm doing is, if it's not my answer, I go into the left side, right? I go into the left side. Let's code this first. Let's code this first. So in this case, as the long is given, so let's write low is pointing to 0 and my high is 0 right now. So here I am writing, okay. So here what I'm doing is I just traverse my array. Okay, inside this array, I just write, I just add all the values into the high, right? And at the end of it, what I'm doing is I also increase by k value, right? Now, let me write here my answer, which is 0. Okay. Now, it's if my answer is 0, what I'm doing here is I just traverse the loop from low to high. Okay. Now, I am finding the mid. Okay. I also do the dry run. Okay. So let me write first. What is my mid is? Mid is low plus high by 2. Okay. Now, what I'm doing is I just pass that value of mid into my helper function, right? Which I already rewritten upward. So let me pass array, okay, the value of r we have and the mid, which we calculate, and the value of k. If this is my answer, if this is true, let's store this answer and my low is going into the right side. Okay. If it's not, what I'm doing is I go into the left side, right? At the end, I just return my answer. As simple as that. Okay. So this point you clear? Okay. So I'm just coloring all the different subarray. Okay, 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 okay. So let's move forward. So I just rewritten that part because I want, like, my time is like maximum time is given to the question part, like dry run part, right? So I don't want to waste time in writing that code, but I just explain all the things to you. Okay. So let me write here. My low is 0, right? My high is 14. Okay. So what I'm doing here is, this is 0. Okay. This is 14. So my mid is 7, right? My mid is 7. Okay. Let me check for 7. It's correct or not? It's correct or not? Okay. Now I am passing that this value to my helper function, right? So just also we have to keep that thing into my mind, right? This we have to keep in mind, these values. We have to use these value as well, right? Now let's disclose this. Okay. Okay. So now we have array, we have R in my helper function, and we have mid, which we have to calculate and tell to the main function it's my answer or not. It may be my answer or not, right? So what I'm doing here is, I just create the n, which is array dot size. Okay. After that, what I'm doing is, I create the sum, which is 0. And now let me do this case first. What is my array? My array is 1 2 4 5 0. 1 2 4 5 0. Okay. Now here my R key value is 1, right? My R key value is 1. In that case, what I'm doing here is, I just add all the values before R into my sum, right? So let me do first here. So my sum here is, okay, when my function value is, when I pass mid equal to 6, sorry, it's 7. Okay, let me write mid equal to 7. When my mid equals to 7 now, when I mid equal to 7, I am checking for that case. Okay, my sum is currently I equal to 1. So I am running the loop. Okay, I am running the loop for R. Okay, here. So what I'm doing here is, sum plus equal to AR of I. Okay, so what's my sum here is 1. Okay, right now my sum is 1. Okay, as you see in my first part, what is my range is 0 to 1 now. In my first case, when j equals to 0, what is my range? 0 to 1. Furthermore, when we move further, what is my range? 0 to 2. Only that thing I do. Only that thing I do in the first case. My sum is 1 because R is 1. Now, please don't read this line first. Okay, just ignore this 44 line right now. Okay, now let's move forward. Now what I'm doing here is, in this for loop, I am checking if R plus I is less than n now, because I don't want to go into the out of bound area, right? If it's true, let me add the array value. Okay, let me add the array value. So here my loop is, if you see I equals to 0, I should go up to n. My R key value is 1. It means my I equals to 0. I plus R. What's the value? What's the sum of I plus R? Which is 1. It should less than n now. Okay, it's less than n. Let me erase this here. Okay, now I'm adding R, I plus R value. What is I plus R? What, this now? Let me add this. My sum is 1. Now my sum is 1 plus 2, right? It should equal to 3. Okay, this should equal to 3. This is a simple case now. 0 to 1. Right now I am not adding that k value, which is 2, right? Okay, right now this is my range when I equals to 0. right? Just see this part. What's my sum is 3. What is your mid, which tell you this may be my answer or not. We have to check this is my answer or not. Here, if my mid is greater now, if you see in the code part, your mid is greater. Can it possible? Can it possible? Because I want maximize the minimum value, right? I want maximize the minimum value. If you see here, my mid is 7 and my sum is 3, right? Just see this thing. My output is 5, right? My output is 5. Can it be 7? Can it be 7? No, it's not. It's not. If you just compare the previous dry run part, when I do for the all cases, I equal to 0, I equal to 1, I equal to 2, right? It's not. But I have k equal to 2, right? Where I'm adding that value, right? If sum is, sorry, if mid is greater than sum, I have k values, I have k operations, right? But k equal to 2 now, k equal to 2. If I give all the value k equal to 2 to this subarray, right? If I do all the value to this now, sum, what will be my sum look like? Sum is 3 plus 2, which is 5. This already less than my mid. This already less than my mid, right? This range is not satisfy that condition, right? It is not my part of my answer, right? Just see this thing. Just see this thing. When j equals to 0, when I equals to 0, j equals to 0. I'm just checking for this case. I'm just checking for this case, right? I'm just checking for this case. Right now, I'm not adding the k value here. Its value is 2, right? Right? Its value is 2 now. Sorry, 3. Its value is 3. If I not adding that k value here, right? Okay. So here if you see, here if you see, my k sum is 6. Sorry, sum is 5, right? Sum is 5. My mid is 7. It is not answer. So that the thing I am writing here. If mid is greater than sum, right? If mid is greater than sum, what I calculate? I calculate how much number I need. So here I'm writing int needed mid minus sum, which is my mid is 7 and my number right now sum is 3. I want 4 more values so that I can tell ki mid is my answer. Mid may be my answer. Mid may be my answer, right? But if you see in the code part, my if my needed is greater than k, yes, it's greater than k. It means we have to return false in this case. We have to return false in this case, right? So here we are returning false, right? So it go into else part where we are decreasing my high value, right, to the left side. So initially this is my 0 low, this is my this. Okay. So my mid is here, right? My helper function tell me that this is not my answer. This is not my answer, right? So what I'm doing here is I just decrease the high value. Right now high is here. I just decrease the high value. High is now pointing to this. So where it is pointing? 0, 6. Okay. Right now my low is here, high is here. Okay. If you see, my mid is in between this, right? Which is 3. Now let's check for the 3 part. Let's check for the 3 part. Again, we have array which is 1, 2, 4, 5, 0. 1, 2, 4, 5, 0. Okay. Here again, what I'm doing is I just add that value where r equal to 1 now. I just add that value which is 1. Let me add 1. Okay. My sum is 1 here. Okay. When sum is 1, I just again traverse the loop from I equal to 0, I less than n. Right. When I equal to 0 and my r is 1, here again the same thing we are doing. Is in the range? Yes, it's in the range. Let's add this. Let's add this. So currently my sum is 1. I'm adding I plus r value into it, which is 1. Let me add this into my answer. 1 plus 2, which is 3, right? It's 3. Now, If you see, if you see in the code part again, your sum is 3 and what's your mid is? What's your mid is? My mid is 3, right? My mid is 3. In this question said, this this equation, not, it's not satisfied. It's not satisfied, right? So what I'm doing is here, if you see in the case, if we are not in this case, right? So also right now you don't assume this line, right? This is for that case when we are out of window range, right? When we are calculating for another window. Right now we are calculating for the when I this range 0 to 1, right? Okay. So in this case, this is passed, right? This sum is passed. Okay. Because my mid is 3, right? Which is less than it. Okay. If you see when I equal to 1, let me write I equal to 1. When my I equal to 1, right? Now my I plus R equal to 2. Okay, this case. So what I'm doing here is my sum is 3 plus 4, which is 7, right? Which is 7. Right now, you are calculated for this range. Just see previous values, 0 to 2 range, right? Your sum is this. If you compare with the mid part, again, it's not in this statement, if statement, right? Now, let's ignore this again because I minus R here is I minus R is not equals to 0, right? It's not greater than equal to 0. My I is 1. Okay. Okay. So if you see here, what I'm doing is if I equal to 1, my answer is 7. This range, this range, I already calculated this. It's not in my mid is less than this value. So I want to decrease the size of it. I want to decrease the range of it. Where first range is 0 to 1, second is 0 to 2. Now I already passed this range. 0 to 2 already passed now. 0 to 2 already passed. Now next range is 1 to 3 now. Next range is 1 to 3. For that, I want to decrease the value of 0, right? I want to decrease the value of 0 so that I can add the value at index 3 now. You understand this? Here the concept is window sliding. We are just doing that part. Here if you see, I is 1, right? R is 1, I minus R, which is 1 minus 1, greater than or equal to 0. Yes, it's equal to 0. Now it's time to decrease the element size, some size from the start of it. Okay. Now we have to create this for, right? For this, we have to delete this. That's why we are adding here this line. And I also write the comment out of window range, right? So we are decreasing that part, right? Sum minus equal to array I minus R. Just neglect this part right now. Addition R minus I minus R. Okay. Okay. So now my sum is uh which is 6, right? I just delete this part. Now, when I move further, I equal to 2. When I equal to 2, in this case, in this case, I plus R. What is I plus R? Which is 3. Which is 3. Right now, what is your sum? 6 plus 3 index, right? Which is 5, 11. You see this part, huh? We are just doing the sliding window. We are deleting this from that last line and we are adding when we are came back to my for loop. Now again, this is satisfied. Again, this situation is going. Never your sum is greater because if your sum pass this condition, also 11 is also passed, we are going further. What I'm doing is I just return at the end true to my helper function so that we conclude from this. Previously we have this, my mid is 3. It tell me like ki 3 may be your answer. 3 may be your answer. So to the main function, this return true. So helper equal to true. So I just store my answer, which is equal to mid, right? Which is equal to mid, which is 3. Now I go further to the right side of it. Let's move forward. Now my low is pointing to this. Okay. If you see here, my low is 4, right? Let me write 4 here and it's 6. Now we are at 5. We are at 5, right? So this is my mid. Again, same step you have to do, right? Again, same step you have to do. This part, okay, this part, right? So in this case, if I already declare my answer as 5, you can assume we get true in this case, right? But as I said earlier, I explained this part later. So addition is here. The addition part is where I'm writing vector of addition. I create the vector of addition. All the value are 0, right? Now in this case, in this case, if I came into this, let's do this for let's do this case also. Okay, so that you can understand it better. So 1 2 4 1 2 4 5 0 1 2 4 5 0. So let me do it quickly. So my sum initially is 1. Okay. Now when I equal to 0, my sum is 3, right? And if you see in this case, if you see in this case, my sum is 3 and mid is 5. It go into this if condition, right? Now it's time to check how much you needed, more points. For example, more elements, right? More sum. So here my needed mid minus what is sum. My mid is 5 and sum is 3. I want 2 more points to reach to that so that I can declare this is my answer. This may be my possible answer. We need 2, right? If you see, my k is also 2. So I can use that k here, right? So what I'm doing here is, what's your needed? Mid minus sum now. If needed is greater than k, no, needed is equal to k, right? Needed is 2, k is also 2. So what I'm doing here is, I increase my sum. Sum previously is 3, I add 2, right? And I delete all the k values, which I already taken, right? So k is 0 here. My sum is reached to this plus needed, which is 2. And what's my k right now? K is 0 because I use all the value, right? So this thing I write in here. Okay. At the end of it, where the addition we are using here now, addition array, right? Why we are using? I just create the addition array where I am using that, my k value. My k value is using at this index I equal to 1, if you clearly see, right? Okay, which is, sorry, k I plus r index, which is 1 index. I is 0, r is 1. I'm using here, right? I'm using here. Okay, so in the end of it, in the end of it, it's not out of bound right now. I'm writing the addition part here, right? So needed is 2, so I'm adding here 2, what I borrow from k. Okay, so right now if you see, my I is 0, right? And r is 0. It's not go into this case, right? After that, my I equal to 1, I equal to 1. In that case, when I equal to 1, I increase my sum value. My sum is 5 here, right? My sum is 5 and I am adding this value into it, which is 9, right? Again, it's greater now. It's greater than my mid. So it's not go into that if condition, right? Now, if you see, this range I already used, right? Okay, so this is 7 because we are using here plus 2 for k already using, right? Now it's time to delete this part. So this I already deleting using this case, where we are deleting array of I minus r, right? We are not deleting the sum value here. What is array I minus r? Array I minus r. Here array I minus r is zeroth value, right? This value. but my sum is 9, right? I delete that part 1, right? But but I want 6. I want 6. That's why we're using this case. Now it's time to delete this also, now 2 part, right? Because I want this part, because I want next to my window is this. So I already delete 1 using this array I minus r, right? It's time to delete what we are using, right? What we are taking from k, that is stored here. That is stored here. So that's why addition of I minus r is also important, right? So we have to delete. When we are deleting this, it's 2, it is 6, right? Now we have 6. It's time to go forward, right? Now it's time to go forward, which is 5. Now we can move forward and we can calculate it, right? After we are calculating this part, I hope you understand till now, right? What's the benefit of addition and what we are doing here. At the end, we are just returning true, right? When we are returning true, when we are returning true, if you see this case, what we have 4, 6, right? We have 4, 6, right? It's true, it's true. Now my low is going from mid plus 1. Now my low is 6, right? High is also 6, right? What is my mid? Mid is also 6. Now, if you are calculating for 6 part now, just do the diagram for 6 part. When you are calculating for the 6 part, it give you false. It give you false. Return false in that case, right? If I get false, if I get false here, if you see low is 6, high is 6, when it's false, it go into the else case. It go into the else case. When it go into the else case, right? When it go into the else case, I have to delete, I have to ignore this part, right? Here we have 6, right? And low is pointing to this, high is also pointing to this. Now my high is pointing to mid minus 1, which is 5. Here the condition of while loop, right? Where when it's cross each other, we have to return our answer. What is my answer? Answer is 5, right? So that's the thing. Our answer is 5. Output is 5 in that case, right? Right. So just do the try run for the last case. You understand it better, right? Now let's check for the time complexity of this code. Simply. So simple time complexity is, let me explain a little bit of time complexity. So if you see here, we are just return the loop here. Okay. Traverse the loop. Let me write here. It's big of n, right? If you see here, what's the maximum number of iteration? As you see, we are using binary search. So simply my complexity here is log of high minus mid, or we can say that high minus low, sorry, high minus low. It's my complexity here, right? Simply, right? So, okay. So now if you see the helper function, we are just traversing our loop to R. Okay. So let's ignore this R. So because this value is smaller, okay, it's equal to n minus 1, we can assume that it's a big of n, right? Let me write here big of n. Okay, so in this case again we are traversing our for loop, right? So it's also big of n. Okay, so what's my helper function? Big of n plus big of n, which is big of 2 into n, which we can say that big of n, right? If you see here, let me write here. So here my complexity is big of n plus big of n into log of high minus low, right? So we can neglect this part also. So simply my complexity is big of n into log of high minus low, right? Okay. So hope you understand all the questions, right? So if you want the code of it, I can also let me give in the comment section. Okay. So you can also do the dry run for your own, like just to understand the question better, the fourth question, right? So if you like the today's contest problems analysis, so please hit the like button, right? So and just share your views in the comment section, right? Can we wrap up this session? If anyone have any doubt, you can also post your comment in the comment section. I am happy to help, right? I also share my views on your comment section, right? If anyone have any doubt, please comment below, right? I also want share my views. Okay. Yeah, okay, thank you, Shubham, thank you so much. So good night, guys. Thank you for joining today's session, right? Okay, bye guys, bye.